Hello, welcome back. If you're here right now, it means the day is finally giving you up. The noise, the tasks, the endless scrolling, all of that is starting to loosen its grip. Isn't it? You can feel it. That slow unwinding happening somewhere behind your eyes. That gradual softening of the muscles in your neck and shoulders. Something in you already knows it's time to rest. Tonight, I want to take you somewhere extraordinary. Somewhere so vast, so impossibly beautiful, so wrapped in silence and starlight that the small worries of your Tuesday or your Friday or whatever day this happens to be will seem very, very far away, because they will be. We're going to go out there into the dark between the stars. We're going to follow a man who made it his life's work to visit worlds that most people only dream of. And as his story unfolds, slowly, gently, with no urgency whatsoever, I hope you find yourself drifting, getting lighter, the weight of the day lifting off you like heat rising from warm stone. There's nothing you need to do right now, nowhere you need to be. Just breathe and listen. Let's begin. Part 1. The man, the ship, and the feeling of leaving. His name was Elias. That's really all you need to know at first. Elias. A simple name for a man who had chosen a very unusual life. He was not famous. He didn't have a face you'd recognize or a name that appeared in headlines. He was, in the truest sense of the word, a traveler. The kind of traveler that most of humanity had never yet been, because the places he traveled to were not cities or mountains or distant coastlines. They were planets. He had been doing this for a long time, long enough that the routine of it had settled into his bones the way habits do. The particular way he folded his jacket before sleeping, the quiet ritual of brewing a single cup of coffee in the small galley before every departure, the soft checklist he ran in his mind before he closed his eyes during a launch. He was the kind of person who had found a way to make the extraordinary feel ordinary, not because he had lost his sense of wonder, but because he had learned to carry wonder very quietly, in a small, warm place inside his chest, and take it out only when the moment was truly right. Tonight, he was leaving Earth's orbit. He had been docked at a way station for several weeks, long enough to resupply, to rest properly, to speak with people on video calls who asked the same kind questions they always asked. "Aren't you lonely out there?" they said, with a kind of cheerful worry. And Elias always smiled and said no, because the truth was complicated. Loneliness and solitude are not the same thing. And Elias had spent enough time alone in space to understand the difference deeply. Loneliness is wanting company and not having it. Solitude is choosing the quiet and finding it full. The way station receded behind him now, its lights blinking in a slow, patient rhythm against the dark. He watched it shrink through the rear viewport for a while, the way you watch a town disappear in a car's rearview mirror, a little wistfully, but without real sadness, because you've chosen the road, and the road is where you belong. His ship was not large. It was called the Meridian, and it was just big enough to feel like a home. A sleeping berth with a small porthole above the pillow, so that if you woke in the night, there was always something vast and speckled to look at. A galley with enough room to stand and turn around comfortably. A workstation covered in instrument panels and soft readout lights, amber, green, the occasional quiet blue that cast a calm, steady glow over everything. The surfaces of the Meridian were worn smooth from years of use, the way good furniture gets worn smooth, developing a kind of personality in the process. This armrest slightly rounded at the corner where he always rested his hand. That console button, slightly shinier than the rest because he pressed it first every single morning. The sound inside the ship was something visitors always remarked on. It wasn't silence. Real silence is rare in any spacecraft because a spacecraft is alive in the way a body is alive, full of working systems and circulating fluids and small mechanical voices. The Meridian hummed. It was a deep, low, steady hum, the kind that lives beneath conscious hearing and only becomes noticeable when you think to listen for it. The ventilation system breathed in a slow, rhythmic cycle. Somewhere in the walls, coolant moved through narrow channels with a faint whisper, and occasionally, at unpredictable intervals, a soft tick from the hull, the ship adjusting to the temperature differential between the sun-facing side and the shadow side. Thermal contraction, the scientists called it. Elias called it the ship settling the way old houses settle at night. He sat in the pilot's chair and let Earth's pull finish releasing him. There's a specific feeling to leaving Earth's gravitational influence. Not a sudden shift, but a very gradual one. Like the moment when a kite string finally goes slack and the kite is simply floating on its own. The body doesn't really feel it. The instruments do. But there's something the mind feels. Some old, deep animal part of the brain that recognizes the change and sends a small, wordless signal. A signal that says, you are very far from home now. And depending on the person, that signal arrives as fear or as freedom. For Elias, it arrived as peace. He set the long-range navigation and stretched out in the pilot's chair, tilting it back until he was nearly horizontal. Through the forward viewport, the stars were thick and still. They didn't twinkle out here the way they did when seen from Earth's surface. That twinkling is caused by atmosphere, by all that moving air between the eye and the light. Out here, with no atmosphere between him and the universe, the stars were simply steady, bright, unwavering points of cold fire. Thousands of them, millions. The longer you looked, the more appeared, filling the dark between the obvious stars with a faint, dusty luminosity that was itself composed of stars too distant to see individually, their light blending into something like a mist. Elias breathed slowly, watching the stars. He was going to Mars first. He always started with Mars, not because it was the most spectacular destination. It wasn't, not compared to what came later, but because Mars was the first world he had ever seen up close, the first alien place that had ever reached through a viewport and rearranged something inside him. Mars was where his sense of the possible had permanently and irrevocably expanded, and so returning to it was always a kind of homecoming. Even though he had never set foot on its surface without a suit, he closed his eyes. The hum of the Meridian was very present in the quiet, very steady, very reliable, in and out. The slow breath of the ventilation, the distant tick of cooling metal, the stars, visible even through closed eyelids if you'd been looking at them long enough, still appearing as faint ghost lights on the inside of your eyes. He was already more than 100,000 kilometers from Earth. He was already, in all the ways that mattered, on his way. The first hour in deep space, past the gravitational community of Earth and Moon, always had a particular texture to it that Elias had never been able to fully communicate to anyone who hadn't experienced it. It wasn't dramatic. There was no moment of revelation, no chime of music from the cosmos. It was more like the feeling after a door has closed and the sounds of a room have stopped, and you're in a corridor, and the corridor is quiet, and the quiet is so complete that you can hear your own body, your own blood moving, your own lungs inflating and deflating. The small internal sounds of being alive that normal life is too loud to let you notice. He had a journal, though he rarely wrote in it. Most of his recording was automatic. The ship's systems kept detailed logs of position, trajectory, environmental readings. But in the personal journal, the handwritten one, there were entries from previous voyages that he returned to sometimes in the early hours of departure. Things he had written after visits to various worlds. They tended not to be the dramatic observations you'd expect. They were usually small things. The specific blue of Earth's limb from orbit, the way a dust devil on Mars looked from above, a thin brown ribbon threading across the plain, casting a wavering shadow. A note about the way Saturn's rings smelled like nothing, which was itself notable because you expected them to smell of something. And the nothingness of the smell inside your suit was its own kind of data about the universe. He put the journal away and dimmed the instrument panel lights down to their lowest setting, just enough amber glow to navigate by if he woke and needed to orient himself. The stars outside were steady and indifferent and beautiful. He pulled the thin blanket over him. Spacecraft blankets were always thin, more for psychological comfort than for actual warmth, and let the hum of the ventilation system be the last thing his waking mind noticed. The Meridian carried him toward Mars through the unpartitioned dark. Part 2. Mars, the Red Desert World. Mars announces itself long before you arrive. You're still days out when it begins to resolve from a point of light into a visible disk. First, just a reddish smear that could be an optical illusion, then, gradually, undeniably, a circle. A small circle at first, pale and faintly warm-colored, like a distant ember. But it grows. Each day it grows. And there's something almost hypnotic about watching a planet grow. It's one of those things that seems like it should be exciting and alarming. And in the moment, it isn't. It's contemplative. You watch it grow the way you watch a flower open, which is to say, slowly, and with a kind of reverential attention that doesn't feel like waiting. By the time Elias was in approach orbit, Mars filled the forward viewport with a presence that was quiet and enormous. The first thing you notice is the color, but calling it red is too simple, too flat. It's the word your brain reaches for at first, and then immediately starts revising. The surface of Mars is red the way a sunset is red, meaning it is also orange and brown and tan and gold, and in the craters and valley shadows, it is deep chocolate and near black. And in the polar regions, it fades to a pale, almost pink, where ice and dust have mixed into a pastel that looks impossibly delicate for a desert world. The iron minerals in the Martian soil have oxidized over billions of years. They have rusted slowly and completely, the way iron left out in all weathers rusts. And that rust color has been picked up by the wind and carried everywhere, dusted into every crack and canyon and crater rim, flung high into the atmosphere where it hangs in a perpetual haze that turns the Martian sky the color of butterscotch. Elias had looked up at that butterscotch sky many times over the years. From inside his pressure suit, on the surface, standing very still with no particular task to perform, and just letting the strangeness of it settle into him. It is not the blue of Earth's sky, not by any degree. It's warm where Earth's sky is cool. It's hazy where Earth's sky is clear. In the hours around noon, it's almost golden. And at sunrise and sunset, the colors invert entirely. The sky goes blue and indigo at the horizon, while the sun sets pale and white, all the colors of a terrestrial sunset flipped. The atmosphere scattering light in ways that have no earthly equivalent. He came low over Valles Marineris in the approach, which was not strictly necessary, but had become one of his quiet personal rituals. Valles Marineris is one of those features that you've seen in photographs probably, and thought you understood. You haven't. Not until you're over it. It's a canyon system, a series of interconnected chasms that stretches across roughly 4,800 kilometers of the Martian surface. If you placed it on Earth, it would reach from Los Angeles to New York. At its widest, it spans 320 kilometers. At its deepest, it drops 7 kilometers below the surrounding plains. It is, by any measure, one of the most staggering pieces of geology in the entire solar system. And Elias never flew over it without feeling the same thing he felt every time. Small. Not small in a frightening way. Small in the way you feel small watching the ocean or the mountains, where the scale of the natural world puts your own scale into a perspective that is clarifying rather than diminishing. You are not nothing because you are small. You are something, a conscious something, capable of looking at this enormous wound in a planet's crust and feeling moved by it. The canyon is simply rock. The being moved, that's the miracle. Today there was a dust storm in the eastern section of the canyon. From altitude, it appeared as a yellowish-red smear. A warm fog nestled down in the deep valleys like a cloud that had fallen and couldn't get back up. Martian dust storms are common. There's almost always one happening somewhere on the planet. The dust on Mars is extraordinarily fine, ground down by wind and collision over billions of years to particles about 5 microns across, on average, finer than talcum powder. Each particle coated with the same iron oxide that gives the planet its color. When a storm picks this dust up and carries it high into the atmosphere, it can take weeks or even months for it to settle again. During the great global storms, which happen roughly once every 3 Martian years, the dust accumulates in the upper atmosphere until it blocks most of the sunlight from reaching the surface, wrapping the entire planet in a warm, reddish-brown murk. The rovers and landers that have sat on the surface of Mars have spent those storms in a kind of patient hibernation, waiting for the light to return. There was something melancholy about that, Elias had always thought. These small machines sitting in the dark and the dust, waiting for the sun. It reminded him of winter, of the feeling of long nights, and the way humans have always oriented their hope towards spring. He passed over the Tharsis volcanic plateau, where 3 enormous shield volcanoes rose above the surrounding plains in a row: Escreas Mons, Pavanis Mons, and Arsia Mons. Each one taller than any mountain on Earth. Each one so broad at its base that from the surface you couldn't see its peak. It would simply disappear over the horizon in the thin atmosphere. And beyond them, impossibly tall even against the scale of everything else, Olympus Mons, the tallest volcano in the known solar system, rising 22 kilometers above the Martian datum. A mountain so large it generates its own weather. A mountain whose base is entirely circled by a cliff face 3 kilometers high. Standing at the base of Olympus Mons and looking up, you would see only a gradual slope extending to the horizon and then beyond. Your eyes would tell you it was flat land, because the curvature of its flanks is so gentle and so vast that perspective plays tricks. Elias lingered in orbit for a day, as was his habit. He spent the hours watching the surface scroll past below him, the terminator line, the boundary between the lit day side and the dark night side, dividing the planet into 2 halves as sharply as a blade. In the night hemisphere, nothing. No city lights, no fires, no glowing evidence of any civilization that had ever lived and worried and wondered. Just the dark and the faint shimmer of starlight on the polar ice cap, he thought about the machines down there, the rovers still working, the quiet instruments, the landing sites of old missions scattered across the surface like the world's most remote monuments. Somewhere in Planitia, the Viking 1 lander had been sitting since 1982. More than 4 decades on the surface, the wind would have scoured it by now. The dust would have accumulated in every crevice. The solar panels, long dead, would be buried beneath layers of silt-fine rust. But it was still there. Humanity's first successful landing on another planet, still present on the surface of that planet, patient and silent. He said a small, wordless hello to it before he fired his engines and headed outward. There was a longer goodbye he sometimes performed, mentally, before leaving Mars. A kind of inventory of the things he had seen and felt and understood differently because of this place. Mars had done something specific to his relationship with time. On Earth, geological time, the millions and billions of years of planetary history, was invisible, entirely theoretical, embedded in rock strata that required expertise to read. But Mars, because it had lost its magnetic field and much of its atmosphere billions of years ago, had stopped actively erasing its own history. The ancient terrain of the southern hemisphere was genuinely ancient, cratered and worn, but still recognizable, a landscape that had not been dramatically altered by tectonic activity or erosion or the relentless biological churning that constantly remodels Earth. Standing in the older regions of Mars, or even just looking at their photographs, was standing in the actual Noachian era, the time in Mars's history from about 4.1 to 3.7 billion years ago, when the planet was warmer and wetter and water flowed across the surface in rivers and gathered in lakes and possibly in a northern ocean. There had been water here. There had been rivers and shorelines and the patient gathering of sediment in quiet water. There had been, and here is where the mind has to stretch, has to make room. There had been weather, an actual weather cycle. Rain, possibly, clouds, certainly, not the thin water ice wisps that occasionally form in the current thin atmosphere, but real clouds, substantial, the kind that make shadows on the ground. And then it had ended. The magnetic field had weakened and died, probably due to the cooling of Mars's smaller core. And without the magnetic field, the solar wind had direct access to the upper atmosphere. Stripping it away molecule by molecule over hundreds of millions of years, the greenhouse gases departed, the temperature dropped, the water froze into the permafrost, and the polar ice caps. The rivers ran dry. All of this was a story written in rock that was there to be read if you had the training and the time. And Elias had spent enough time around planetary scientists to see it too, to look at a canyon wall and understand the layers not as abstract geology, but as chapters in a narrative about a world that had tried its best with what it had and eventually run out of the means to maintain itself. He found this sad in the way that all endings are sad. But not only sad, there was something dignified in it. The long record of a world doing what worlds do, changing and struggling, and ultimately subsiding. The silence of Mars now felt earned rather than empty. The stillness felt appropriate. Whatever this world had been it completely. He fired the engines and Mars shrank behind him. The asteroid belt took time to cross, but it was not the traffic jam of rocks you might imagine from films. Space is simply too vast. The average distance between asteroids is hundreds of thousands of kilometers. You could fly through the entire belt without even seeing most of them. They would be invisible, too small, and too far. Occasionally, one of the larger ones swam into the distance, a potato-shaped rock tumbling very slowly in the eternal quiet, catching the distant sun on one facet at a time. Elias watched them go by with a kind of companionable fondness. They were the leftover pieces, the building material that never got used, orbiting patiently in their long ellipses, going nowhere in particular and in no hurry. Beyond the belt, the sun began to shrink. It's a thing people don't always realize, how dramatically the sun changes appearance as you leave the inner solar system. From Earth's surface, the sun fills about half a degree of sky, a brilliant and dominating presence. By the time Elias cleared the asteroid belt and began the long approach to Jupiter, the sun had already shrunk noticeably. It was still bright, still the brightest object in the sky by an enormous margin, but it had lost some of its authority. It was becoming, gradually and inexorably, just another star, though a very close and very powerful one. There was something philosophically interesting about that shift. Elias had always thought the gradual dethroning of the most central object in the sky, the long, slow reminder that even the sun is just a star, and there are billions more. Jupiter lay ahead, still too far to see as anything but a bright dot. He slept. Part 3. Jupiter, the giant's kingdom. Nothing in the inner solar system can prepare you for Jupiter. Not the photographs, not the data, not the intellectual knowledge that you've carried your whole life about what the largest planet in our solar system actually is. The numbers are available to anyone. More than 1,300 Earths could fit inside Jupiter. Its great red spot is a storm wider than 2 Earths placed side by side. Its magnetic field is the strongest of any planet. Its winds peak at over 500 kilometers per hour. It has at least 95 moons of varying sizes and strangeness. You can know all of this and still be entirely unprepared for what happens when Jupiter begins to fill your viewport. Elias had made this approach more than a dozen times. He was still never prepared. The planet arrives first as a disk of unmistakable complexity. Where Mars was simple in its coloration, broadly red, broadly orange, broadly dusted, Jupiter is layered and detailed and alive with weather patterns that could each swallow a country. The cloud bands are the first thing your eye organizes. Dark ochre belts alternating with lighter cream-colored zones, wrapping the planet in parallel stripes that run east to west, as consistently as a fingerprint, and yet always slightly different in the details, always shifting in ways that require continuous observation to fully appreciate. The belt and zone structure of Jupiter's atmosphere is driven by the planet's extraordinary rotation. One full day on Jupiter takes just under 10 hours, which means the equator is moving at roughly 45,000 kilometers per hour. This rapid rotation stretches weather patterns into those horizontal bands, sorting the rising and sinking atmospheric currents into parallel streams that flow in opposite directions. The dark belts are regions where gas is sinking, compressing, warming slightly. The lighter zones are where gas is rising, expanding, cooling, and the boundaries between them are where the interesting things happen. The swirls and eddies and oval storms that appear and persist and occasionally vanish without warning. The storms. Jupiter is a world of storms. Not the episodic storms of Earth or Mars, tied to seasons and temperature cycles and moisture, but something more permanent. more geological. The Great Red Spot, which Elias could see now from orbit as a red-orange oval set into the southern hemisphere, like a gem set into a ring, has been observed by astronomers for well over 150 years and may have existed for much longer. It is a high-pressure anticyclonic storm, meaning it rotates in the opposite direction from hurricanes on Earth. Its winds at the outer edge reach roughly 430 kilometers per hour. It extends not just across the surface but downward. Recent data from NASA's Juno spacecraft suggested the storm reaches at least 300 miles deep, below the visible cloud tops, perhaps deeper. It is, in short, not a surface feature, but a deep structure, a column of rotating atmosphere that may extend hundreds of kilometers into the planet. And yet, even this titanic thing is shrinking. Observations over decades have shown the Great Red Spot slowly contracting, becoming more circular as it reduces in size. Scientists estimate it will eventually stabilize into a smaller, rounder configuration, trapped between two jet streams that constrain its latitude, unable to drift north or south. The idea of this storm, hundreds of years old, ancient by any human measure, slowly finding a new equilibrium, there was something in that thought that Elias always found calming. Even the most violent things find their balance eventually. He settled into a broad equatorial orbit and simply watched for hours. The atmosphere of Jupiter is composed mostly of hydrogen and helium, the same basic recipe as the Sun. But in the cloud layers, other chemicals appear. Ammonia, crystallized into white and yellow ice clouds. Ammonium hydrosulfide, forming the oranges and reds and browns. Water ice and water vapor deeper down, in the warmer layers where the pressure grows. Substantial, the exact chemistry of Jupiter's coloration is still an active area of scientific investigation. Scientists have proposed that cosmic rays and ultraviolet radiation interact with these compounds to produce the complex organic molecules that generate the reds and oranges. But the precise recipe remains somewhat mysterious. You can smell planets if you're willing to be imaginative about it. Not literally, of course. Elias was safely behind glass and suit fabric, but standing outside on the surface of Mars, he had always imagined a faint mineral dryness, the smell of oxidized iron and cold stone. Jupiter, he had always thought, would smell of something sharper, something electric, the way the air smells before a lightning storm, multiplied 10,000 times. There is lightning on Jupiter, enormous lightning. The bolts are estimated to be 3 to 5 times more energetic than the strongest lightning on Earth, and they occur most frequently near the poles. Where Juno detected them crackling through the cloud layers in bursts, he watched a string of oval storms drift eastward along one of the belts, small by Jupiter standards. Each one still the size of a terrestrial continent, each one white and clearly defined against the darker band. They moved with a stately, indifferent grace, carried by the jet stream at a speed too slow to perceive in real time, requiring time-lapse to appreciate. Everything on Jupiter operates on a scale that makes normal human time feel inadequate. Elias found this profoundly restful. There is something deeply settling about scale. When you are confronted with things that are genuinely, comprehensively, indifferently vast, things that are not vast to impress you but simply because that is what they are, the mind does something interesting. It stops trying to contain. It stops trying to manage. It gives up in a particular way that feels like relief, like setting down a heavy bag, like the release of something held too long. You become, for a moment, perfectly present and perfectly small. And both of those things feel wonderful. he drifted in Jupiter's orbit for a full day and night, which is to say, for the full rotation of the planet, 10 hours of Jupiter time, during which he watched the great red spot complete most of its own rotation within its storm system, watched new cloud formations emerge and others dissolve, watched the 4 largest moons, the Galilean moons, trace their paths through the dark, Io, volcanic and orange-yellow, perpetually resurfaced by hundreds of active volcanoes. Europa, icy and white, its cracked surface hiding a deep saltwater ocean beneath. Ganymede, the largest moon in the solar system, larger than the planet Mercury. Callisto, ancient and cratered in dark, a record of billions of years of impacts preserved in its surface. Each of these moons was a world in its own right. Each deserved a voyage of its own. Elias nodded them, as he always did, with a kind of fond regret. He couldn't stop everywhere, couldn't linger at every wonder. The itinerary was long, and the stars did not move faster to accommodate curiosity. He pointed the Meridian's nose toward Saturn and let the giant's gravity sling him forward. Hash, Part 4. Saturn, the Ringed Wonder. Saturn is the most beautiful planet in the solar system. This is not an objective statement. Beauty is never objective. But Elias had visited every major world in the solar system at this point in his career. And no matter what order he ranked the others, no matter how he shifted the criteria or changed his mood, Saturn always came back to the top. It is the rings. You've seen them in photographs, of course. And the photographs are genuinely beautiful. There are images taken by the Cassini spacecraft during its 13 years in Saturn's orbit that belong among the most remarkable images ever made. Images that stop conversations, that make people put down their phones and just look. But photographs do not capture the dimensionality of the rings when you are actually there. From a photograph, the rings look flat, two-dimensional, like a disk of paper wrapped around the planet. From orbit, they reveal their depth and their geometry in a way that no photograph fully conveys. The rings of Saturn extend outward from the planet's equator to a distance of roughly 282,000 kilometers from the planet's center, but they are extraordinarily thin. The main rings are typically less than a kilometer thick, sometimes far less. The ratio of diameter to thickness, if you scaled the rings to the size of a sheet of paper, would make them far thinner than that paper. They are, in proportion, one of the flattest objects in nature. From the right angle, when Elias positioned the Meridian to catch the rings edge-on against the sun, they all but disappeared, resolving into a needle-thin line of light so delicate it seemed impossible. Then he adjusted his orbit, changed the angle, and the rings swelled back into their full majesty, a broad band of ice and rock that scattered sunlight in 1,000 different ways, depending on the particle size and density. Some sections opaque, some sections deeply shadowed, some gleaming. The main rings are composed mostly of water ice, with chunks ranging from tiny grains to lumps the size of houses. Each particle orbits Saturn independently, following the same gravitational laws as any moon, staying in its track with the quiet order of something that has been doing this for billions of years. Between the rings, there are gaps. The most prominent is the Cassini division, a dark gap roughly 4,800 kilometers wide that separates the B ring from the A ring. It looks empty, but it isn't. It contains a sparse population of particles, less dense than the rings on either side, cleaned out by the gravitational influence of Saturn's moon Mimas. Mimas sits in a resonance with this region, its gravity nudging any particles that drift into the gap outward over millions of years, sweeping it relatively clear. Elias let himself hover at the inner edge of the rings for a while, relatively speaking, in the way that hovering in orbit is possible. Below him, Saturn's upper atmosphere was striped in pale gold and cream, cooler and quieter than Jupiter's drama. The bands gentler, the storms less obviously violent, though the jet stream at Saturn's equator blows at roughly 500 meters per second, which is faster than most things on Earth that move at all. Saturn lacks the vivid reds and oranges of Jupiter. Its palette is all pale ambers, cream whites, and hints of blue at the poles, where the atmosphere is thinner and the sky shows through. In 2013, NASA's Cassini spacecraft photographed a hexagonal jet stream pattern at Saturn's North Pole, a genuine geometric hexagon in the clouds, roughly 32,000 kilometers across. So regular and so improbable looking that the first images were thought to be a processing error. They weren't. It persists, a weather phenomenon produced by standing wave patterns in the polar jet stream. A perfect hexagon, turning slowly on a gas giant, one of the most striking things the solar system has ever produced. On the horizon of Saturn's atmosphere, if horizon is even the right word, if you can call the fuzzy gradient between planet and space a horizon, Titan was visible. Saturn's largest moon and the only moon in the solar system with a dense atmosphere. Titan's atmosphere is mostly nitrogen, like Earth's, with methane playing roughly the role that water plays on Earth. It exists as a gas, a liquid, and a solid, cycling through the surface and atmosphere in a weather system that mirrors our own in structure, while being utterly alien in substance. There are methane rivers on Titan, methane lakes, methane rain falling from methane clouds through a sky of orange nitrogen smog. If you could stand on Titan's surface, under that thick orange sky, with the distant sun no brighter than a cloudy day and the minus 179-degree cold, you would be standing on a world that feels like a dream of Earth rather than the actual thing. Familiar structure, utterly alien substance. Elias watched Titan from a distance, its surface completely invisible. Beneath the haze, only the outline of it readable, a slightly darker disk against the stars. He thought about water. Water was, in so many of these places, the thread, the thing that connected them. Jupiter's Europa, with its deep ocean. Saturn's Enceladus, a small moon not visible from here, with its geysers of water vapor jetting from the South Pole. A subsurface ocean expressing itself in plumes. Titan with its methane seas and possible liquid water layer beneath the ice. And all of these worlds held, in the back of every scientist's mind, the same question. Is something alive in that water? Has something found a way, in the pressurized dark of an icy ocean, to organize chemistry into life? We don't know. We genuinely don't know. And the not knowing is not a failure. It is an invitation. The rings of Saturn caught the sun at a low angle as Elias began his departure burn. And for a few minutes, the ice scattered the light into something that was almost iridescent. Pale blues and whites and silvers rippling along the ring plane as the geometry shifted. He watched it until it became too bright to look at directly. And then he looked away. And when he looked back, the rings were simple and white again. He was sorry to leave. He was always sorry to leave Saturn. There was always one more thing to look at when you were at Saturn. The shepherd moons, tiny moonlets embedded within the rings themselves, gravitationally herding the ring particles at their orbit's edges, maintaining the sharp, clean boundaries between ring sections as neatly as a farmer maintaining a fence. Pan, the small moon embedded in the Inca Gap, shaped by the ring material that has accumulated on its equator into something like a flying saucer, a disc-shaped moon with a prominent equatorial ridge, Atlas, similarly shaped, nestled in its own gap. These moons were both the product of and the sculptors of the rings around them. They cleared their gaps by sweeping up particles, and the particles that fell onto them formed their strange shapes. He had thought, during an earlier Saturn visit, about how much of the solar system is in dynamic conversation with itself. The rings of Saturn were not a static decoration. They were in a constant gravitational dialogue with dozens of moons, each one nudging and being nudged, the whole system a slow, patient, endless negotiation between orbital mechanics and the accumulated consequences of billions of years of interaction. Some of the ring material was relatively young. Estimates suggested the main rings had formed somewhere between 10 and 100 million years ago, likely from the breakup of a moon or a captured comet. On geological scales, this was recently. The rings might, from a long enough perspective, be a temporary feature, growing, being added to, being slowly eroded, eventually dispersing or falling into Saturn altogether. The idea of Saturn without its rings was almost philosophically disturbing, the way the idea of a landscape without a familiar hill or tree is disturbing, not because the loss would be catastrophic, but because the familiar and the beautiful are always worth mourning in advance. But that was billions of years away. For now, for a long, long now, the rings were there. He let himself drift one more time along the ring plane, close enough that individual ring particles were just barely visible as glints. A swarm of ice chips and snowflakes orbiting in a precision that would never be fully appreciated by anything except the mathematics that governed it and turned the meridian outward. But the outer solar system was calling. Part 5. Uranus, the tilted world. The farther out you go, the quieter space becomes. This is not a measurable thing. The instruments don't record it. The vacuum of space is the same vacuum whether you're near the sun or far from it. There is no air out here. There has never been any air out here. The silence is total and absolute in every direction at every distance. But the human mind perceives the outer solar system differently. Maybe it's the reduced sunlight which drops by the square of the distance. At Uranus, the sun delivers only about 0.3% of the light it delivers at Earth's orbit. Maybe it's the longer distances between objects, the sense of being truly alone in a very large volume of space. Maybe it's simply the time it takes to get here, the long cruise that gives the mind time to settle, to quiet, to find a different register. Whatever the reason, by the time Elias was on approach to Uranus, he was already moving more slowly in his own interior. Not sleepy, exactly. More like the feeling of a long Saturday afternoon when there's nowhere to be. A kind of unhurried, open-ended presence. Uranus is, at first encounter, strange in its quietness. Jupiter announces itself with violence. The storms, the lightning, the dramatic banding. Saturn announces itself with beauty, the rings, the golden light. Uranus announces itself with something more subtle. From a distance, it looks almost featureless, a smooth greenish-blue sphere that gives very little away. The color comes from methane in the upper atmosphere, which absorbs the red end of the visible spectrum and reflects back the blue and green, giving the planet a cool, aqueous appearance. It doesn't blaze. It glows softly, like something illuminated from within by a very gentle, very diffuse light. The featurelessness, it turns out, is partly an artifact of when we first saw it up close. When Voyager 2 flew past Uranus in January 1986, the planet happened to be presenting its pole toward the Sun, because Uranus is tilted on its axis by nearly 98 degrees, meaning it effectively rolls through its orbit rather than spinning upright. This dramatic tilt means that one pole spends 42 years in continuous sunlight, while the other spends 42 years in continuous darkness. And during the Voyager flyby, the southern polar region was in the midst of its 42-year summer. The uniform heating produced a relatively featureless atmosphere compared to the dynamic storms of Jupiter. More recent observations, as Uranus has moved toward equinox and then toward northern summer, have shown more activity, bands appearing, storms forming, the atmosphere revealing that it does in fact have weather. Just weather that runs on much longer timescales than the hourly drama of Jupiter. What lies beneath those smooth blue-green clouds is anything but serene. Uranus is an ice giant, which means it is not primarily composed of gas the way Jupiter and Saturn are, but of what scientists call ices, water, methane, and ammonia in a hot, dense, slushy state under enormous pressure. Near the core, the temperature may reach 9,000 degrees Fahrenheit, but the pressure is so extreme that this heat cannot easily escape. The planet's interior is effectively trapped, insulated, the heat locked away. This is why Uranus radiates almost no excess heat into space. Unlike Jupiter and Saturn and Neptune, which all emit significantly more energy than they receive from the Sun, Uranus holds its warmth. There is a theory, still speculative, one of those beautiful scientific ideas that hovers at the edge of what instruments can yet confirm, that deep inside Uranus, under pressures of millions of bars, the carbon in methane is squeezed out and compressed into diamonds. Diamond rain, tiny crystals of pure carbon falling through the pressurized interior of the planet, accumulating perhaps at the core, billions of tons of diamond, compressed into a layer that no human hand will ever touch. This same process is thought to occur on Neptune and potentially on Saturn. The interior of the ice giants may be, in some deep layer, the most diamond-rich environment in the solar system. Elias thought about that sometimes. The diamonds no one would ever see. The beauty that existed purely for its own sake, with no audience, no witnesses, no purpose beyond the patient physics of the universe doing what it does. He found this very comforting. He spent a quiet day at Uranus, orbiting in the strange greenish light, watching the planet turn in its sideways roll, watching the moons, Miranda, Ariel, Umbriel, Titania, Oberon, trace their orbits in planes that felt all wrong to the eye accustomed to other planetary systems, orbiting in the equatorial plane of a tilted world, and therefore orbiting in a way that from outside looked almost vertical rather than horizontal. They were small moons mostly, but Miranda, the innermost of the 5 major ones, had been hit by something enormous early in the solar system's history and shattered, then slowly reassembled itself through gravity, producing a surface that looks unlike anything else in the solar system. Sheer cliffs kilometers high, canyons and ridges and grooves that suggest a world that came apart and put itself back together without quite managing to match up all the pieces. There are places on Miranda where canyons drop for 20 kilometers straight down. Verona Rupes, the tallest known cliff in the solar system, a fault scarp nearly 20 kilometers high. If you dropped a stone from the top of Verona Roops on Miranda in its low gravity, it would take about 10 minutes to reach the bottom. Elias sat very still in the pilot's chair, thinking about falling stones. Time. Out here, everything was about time. The slow processes, the long cycles, the unhurried accumulation of small changes into large transformations. Miranda falling apart and coming back together. Uranus rolling through its 84-year orbit each pole spending most of a human lifetime in either light or dark. The ring system of Uranus, faint, dark, difficult to see, composed of particles of some of the darkest material in the solar system, possibly organic compounds blackened by radiation, orbiting in thin and tidy lines. He breathed and watched and let the greenish light wash over him. Then he aimed the Meridian toward the deep blue that was Neptune, the last of the classical planets, 4 times farther from Earth than where he now sat. Part 6. Neptune, the windswept deep. Neptune is the color of a dream about the ocean. There is something almost unreal about it when it finally resolves clearly in the viewport. A blue that seems too vivid, too decided, too specifically the blue of a deep water sea to be a world made of gas and ice at the far edge of the solar system. But this is the real color, or close to it. For decades, images released by NASA showed Neptune as a rich, deep cerulean and Uranus as a pale, washed-out teal. And people assumed they were genuinely different colors. A 2024 study corrected this. The 2 planets are actually more similar in hue than people thought, both a kind of blue-green. But Neptune's atmosphere is more active, and that activity keeps its haze layer thinner. And the thinner haze means the blue shows through more clearly, giving Neptune its vivid, saturated appearance. Wherever the truth of the color lies, Neptune from orbit is extraordinary. And the first thing the instruments tell you, the thing Elias always registered almost immediately after the visual impression settled, was the wind. Neptune is the windiest planet in the solar system. Not the windiest compared to what you'd experience standing on its surface. You cannot stand on its surface, only gradually increasing pressure and temperature as you descend through layers of cloud and ice until you reach the rocky core buried in conditions no machine humanity has built could survive. But the wind speeds measured in Neptune's upper atmosphere reach over 2,000 kilometers per hour, more than 1,200 miles per hour. The fastest winds on Earth in the strongest hurricanes peak at around 400 kilometers per hour. Neptune's supersonic winds make those look like a gentle breeze. They flow retrograde, opposite to the planet's rotation, which is in itself something of a mystery, since Neptune's internal heat is thought to be what drives them. The planet emits 2.6 times more energy than it receives from the sun. It glows faintly in its own infrared warmth. This internal heat, interacting with the cold of space and the planet's composition, creates temperature gradients that drive the extraordinary winds. Neptune has storms. They come and go. When Voyager 2 flew past Neptune in 1989, it found a vast, dark oval in the southern hemisphere, the Great Dark Spot, roughly the size of Earth. It seemed like a permanent fixture, a Neptune equivalent of Jupiter's Great Red Spot. But when the Hubble Space Telescope turned its gaze toward Neptune in 1994, the Great Dark Spot was gone, vanished. In its place, A new dark spot had appeared in the northern hemisphere. Neptunian storms, it seems, don't last centuries the way Jupiter's does. They form, persist for a few years, and disappear, replaced eventually by other storms. The atmosphere of Neptune is dynamic in a different way from Jupiter's permanence, more volatile, more changeable. The weather patterns shifting with something approaching unpredictability. Elias had arrived at a quiet period. There was a small dark spot visible near the southern pole, but no major storms. The atmosphere was streaked with high-altitude clouds of methane ice, white and wispy against the deep blue background, moving so fast that their motion was perceptible over the course of hours of observation. They raced across the planet's face in long streaks, east to west, driven by the jet streams below. Triton hung in the distance, Neptune's largest moon, and one of the most unusual objects in the solar system. Triton orbits Neptune backward, retrograde, in the opposite direction from Neptune's rotation. This is nearly unheard of among large moons, and it tells us that Triton was not born with Neptune. It was captured long ago from somewhere else, most likely from the Kuiper Belt, that vast region of icy bodies beyond Neptune. Gravitational capture is a violent process. Triton would have entered a highly elliptical orbit that gradually circularized over millions of years, its tidal interaction with Neptune slowly grinding its orbit into the near-perfect circle it now occupies. This same tidal interaction heats Triton's interior and may maintain a subsurface ocean beneath its ice shell. Triton has geysers. In 1989, Voyager 2 photographed dark plumes erupting from Triton's surface, rising several kilometers above the terrain before being blown downwind into dark streaks on the ice. The geysers are powered not by internal heat, but by solar energy, even this far from the sun. The sun's light, faint as it is out here, penetrates Triton's thin layer of surface nitrogen ice and warms the darker material below. This trapped heat vaporizes the nitrogen, which then explosively vents upward through the ice, carrying dark dust with it. Geysers on a moon 4.5 billion kilometers from the sun, powered by sunlight that by this distance arrives at barely 1/1000th the intensity it has at Earth. Elias watched Triton for a long time. He watched its surface, pale and salmon-colored in the infrared, patterned with what are called cantaloupe terrain, a strange landscape of pits and bumps that looks vaguely like the skin of a cantaloupe melon, believed to form through the diaperism of rising ice. He watched the geysers, too small to see as individual events, but the plume's dark streaks on the surface told the story of all the ones that had happened before. Out here, at the edge of the classical solar system, the sun had dwindled to something much more humble. Still the brightest object in the sky, still unmistakably the sun, but diminished. It was now not much larger in apparent size than the most brilliant stars. Its light was cold and faint. If you held your thumb out at arm's length, you could cover it entirely, and yet it was still enough. Still enough to power geysers on a distant moon. Still enough to cast faint shadows. Still enough for the instruments of the Meridian to run their solar cells at a low but functional level. The sun's reach is long. Beyond Neptune, in the dark zone between the planets and the stars, lay the Kuiper Belt, the region from which Triton had almost certainly come. a vast population of icy bodies stretching from about 30 to 50 astronomical units from the Sun. Pluto lived there, and its moon Charon, and thousands of other frozen worlds of varying sizes that had never grown large enough to dominate their neighborhoods. Each one an ancient, cold record of the early solar system's chemistry. Elias had visited Pluto once on an earlier journey. He had stood at the edge of its nitrogen plains and looked up at the sky, faintly blue in the thin atmosphere, with the sun a genuinely stellar-looking point of light, intensely bright but diskless, just a pinpoint brighter than any star seen from Earth. Charon had hung in the sky like a world-sized moon, gray and cratered, its presence so close that Pluto and Charon spent their orbital lives facing the same side toward each other, locked not just in orbit, but in a kind of perpetual, mutual gaze. Two worlds, tidally bound, watching each other across a gap of roughly 19,000 kilometers. He had found Pluto surprisingly textured, surprisingly dynamic for a world at the edge of everything. Its heart-shaped feature, a vast nitrogen ice plain that scientists had named Tombaugh Regio, was pale enough to see from orbit, a lighter region in the mottled landscape of frozen water and tholin chemistry. The tholins gave Pluto its ruddy orange color in places, complex organic molecules produced when nitrogen and methane in the atmosphere were bombarded by ultraviolet light and cosmic rays, settling onto the surface and staining it in colors that were almost warm, almost autumn-like, incongruously so, for a world where the temperature was below -220 degrees Celsius. There was beauty at the edge of everything. Elias had always found beauty at the edge of everything. He filed away the memories of Pluto and returned his attention to Neptune, now below him in its vivid blue. Elias spent 2 days at Neptune, drifting in that vivid blue light, letting the extraordinary distance from everything familiar do what it always did. Settle him, clarify him, strip away the complications. And then he looked outward, past Neptune, past the Kuiper Belt, past the heliopause, where the sun's wind finally gives up against the pressure of interstellar space, out toward the stars. Tonight, he was going farther than he had ever gone before. Part 7, Into the Deep, the long voyage to the stars. There is a moment in any long journey when the thing you're leaving becomes smaller than the thing you're approaching. For Elias, this moment came somewhere in the vast dark between Neptune and the TRAPPIST, one system. He had passed the heliopause, that boundary where the sun's influence ends and interstellar space truly begins, where Voyager 1 had made its historic crossing in 2012 after traveling for 35 years. He had passed into the interstellar medium, the thin soup of gas and dust that fills the space between the stars, the medium through which radio waves from Earth travel, thinning and weakening as they go, broadcasting the noises of human civilization outward in an expanding sphere at the speed of light. Out here, the silence was different. Inside the ship, the familiar sounds remained, the hum, the breath of ventilation, the occasional soft tick. The instruments talked to each other in their own language. But outside there was nothing, no solar wind, no magnetic field bubble, no charged particle streams, just the cold interstellar medium, so thin as to be essentially nothing, a few atoms per cubic centimeter, a vacuum so complete that the best vacuum chambers on Earth are crowded by comparison. The stars were extraordinary from here. Without any planetary glow or reflected sunlight competing with them, without the faint scattered light of the sun's neighborhood, the stars were simply everything. The Milky Way, the disk of the galaxy viewed from inside, stretched in a luminous band across the sky. Not a metaphor, but a literal river of stars, so densely packed that their individual lights blended into something that looked like spilled milk, like smoke, like something that language was invented before humans had to describe it, and therefore had no really adequate words for. It was beautiful in a way that removed language entirely, that replaced words with breath. Elias knew, of course, that each of those points of light was a sun, that most of them had planets, that we had confirmed more than 6,000 of those exoplanets by the time he left Earth, and the real number was understood to be billions. Most stars with at least one planet, many with systems of several. The universe had turned out to be relentlessly ordinary in this respect. Planet forming was simply what stars did, the way water forms droplets, the way gravity pulls things together. Planets were not special exceptions. They were the default. What was special? What remained special? What kept the scientists and the dreamers and the travelers awake at night? Was the question of which of those planets had ever been able to sustain anything that thought about the question of whether other planets had ever been able to sustain anything. That recursiveness, that strange loop, the universe containing minds capable of wondering about itself. He set course for TRAPPIST-1. The journey took a very long time. Even in the way of his story universe, where such journeys are possible, he passed through the interstellar darkness in long periods of sleep and waking, watching the target star grow from a red point to something slightly less of a point, watching the stars around him slowly, imperceptibly slowly, shift in their positions as his angle of view changed. Stellar parallax, the slight apparent movement of nearby stars against the background of distant ones as your viewing position changes. The same phenomenon that lets your two eyes, separated by just a few centimeters, triangulate the depth of the objects around you. Out here, needing to travel light years to produce a measurable shift, the effect was slow and grand in scale. He passed a rogue planet in the dark. A rogue planet is a world without a star, untethered, drifting through the interstellar medium, its own internal heat, the only warmth it has ever had. This one was too dark to see with the naked eye, but his instruments registered it. A gravitational ripple, a faint heat signature, a presence in the dark. He estimated it was roughly Earth-sized, rocky, utterly cold on the surface, hundreds of degrees below zero. No light, no seasons, nothing growing. Just the long drift and the internal warmth of radioactive decay deep in the rock, far too faint to do anything useful. And yet, there were scientists who had proposed that even rogue planets might harbor life. Not on the surface, never on the surface, but beneath it, in subsurface oceans kept liquid by geothermal heat and antifreeze chemistry. In the deep rock, where chemotrophic bacteria don't need sunlight at all, only chemistry, only the slow energy of minerals reacting with water. Life, in that scenario, would be the deep and patient kind, the kind that doesn't know stars exist because it has never experienced light, the kind that metabolizes rock and calls it a good day. Elias had spent a lot of time over his career thinking about what life actually required. Earth life required sunlight, oxygen, liquid water, a reasonably stable temperature, a magnetic field to deflect radiation, a long list of specifics that had seemed, before the era of exoplanet science, to represent the universal requirements. But the more worlds were found, the more those specifics had turned out to be preferences rather than requirements. Life on Earth had been found in volcanic vents at temperatures above boiling point, in hypersaline lakes with chemistry hostile to almost everything, in Antarctic ice, in the upper atmosphere, in rock cores drilled kilometers below the surface. Life on Earth, when you looked closely, was not a delicate flower requiring perfect conditions. It was more like an extremely enthusiastic experiment that would try absolutely any available substrate. If this was true on Earth, the expectation had to be that life, wherever it arose, would have the same quality, the same relentless willingness to try. The universe, he had come to believe, was not inhospitable to life. It was more accurate to say that the universe was aggressively neutral, neither helpful nor harmful, simply providing physics and chemistry and time and leaving the rest to whatever local conditions happened to produce. Time was the key ingredient. 7.5 billion years for TRAP. PIST-1. That was time enough for life to arise and develop and complexify through stages we couldn't yet imagine, through cellular elaboration and multicellular organization and whatever complexity came after that, if anything did. Or it was time enough for chemistry to elaborate into something that always stayed at the level of single cells, patient and sufficient and needing nothing more. Both outcomes were coherent. He let the rogue planet fall behind him and thought about the patience of life, the patience of things that exist without needing to be witnessed. TRAP, PIST, one grew in the viewport. Part 8, the TRAP, PIST, one stem, 7 worlds around a red candle. TRAP, PIST, 1 is 40 light years from Earth, in the constellation Aquarius, a star so dim and so cool that the astronomers who discovered it named the classification it belongs to ultra-cool dwarf. It has a surface temperature of about 2,566 degrees Kelvin. Compared to the Sun's roughly 5,778 degrees, its radius is barely larger than Jupiter's. Its mass is about 9% of the Sun's. If you saw it in the sky without knowing what it was, you might possibly mistake it for a brown dwarf, that class of objects that nearly formed stars but didn't quite have enough mass to sustain hydrogen fusion. But TRAP, PIST, one does fuse hydrogen, barely, at the low end of what's possible, but it does, and it will continue to do so for an extraordinary amount of time. While our sun will exhaust its hydrogen fuel in about 5 billion years, TRAP, PIST, one will burn for roughly 10 trillion years. The current age of the universe is about 13.8 billion years. TRAP, PIST, One will be shining long after every other star currently visible in the sky has gone dark. It is, in the truest sense, a patient star. It was discovered as a planet host in 2016, when astronomers using the TRAPPIST telescope at La Silla Observatory in Chile detected the characteristic dimming that occurs when a planet passes in front of a star, then another dimming, then another. By 2017, the full picture was revealed. 7 planets, all roughly Earth-sized, orbiting this tiny red star in tight, overlapping loops. 7 Earth-sized worlds around one star. The most such worlds ever found in a single system at that time. The scientific community had been excited, to say the least, as Elias approached TRAPPIST-1. It showed itself not as the blazing disk of our sun, but as a deep, dark red ember in the sky, the color of a campfire coal, the color of heated iron that hasn't quite reached glowing orange yet. A red so deep it was almost brown. The light it cast on the Meridian's hull was not the clean white of solar light, but something warmer and dimmer, like light through curtains in the late evening. He could see the planets, not all of them at once, not from this distance, but they were there, close enough to their star that their orbital periods ranged from just 1.5 days for the innermost to 19 days for the outermost. The entire system would fit inside the orbit of Mercury around our sun. The 7 planets orbited so close together and so close to the star that if you stood on any one of them and looked up, you would see the other planets as visible disks in the sky, some of them as large as our moon or larger. Standing on planet D and looking toward planet C, you would see a world, a real world with geography and perhaps an atmosphere, as a disk clearly visible to the naked eye. The proportions of the TRAPPIST-1 system, astronomers had noted, resembled Jupiter and its moons more than our sun and its planets. Elias slowed the Meridian and began a careful approach. The innermost 3 worlds, B, C, and D, were closest to the star and probably hostile. TRAPPIST. 1, B, and C had been studied extensively by the James Webb Space Telescope, and the results were unencouraging for life seekers. Planet B showed a dayside temperature consistent with a bare rock absorbing the star's energy with minimal atmosphere. Planet C, despite being in a somewhat more comfortable position, showed thermal emission suggesting its dayside was very hot, too hot for thick carbon dioxide-based atmosphere, most likely a bare, rocky world. Planet D was borderline, possibly hot, possibly maintaining some thin atmospheric chemistry, possibly one of those worlds that, like Venus in our own system, had once been more moderate, and had then, through some cascade of changes, tipped past the point of no return into something inhospitable. But planets E, F, and G, these were different. These 3 orbited within what scientists call the habitable zone of the TRAPPIST-1 system. The range of distances from the star where the temperature could theoretically allow liquid water to exist on a rocky surface. And the crucial word is theoretically. The habitable zone is not a guarantee. It's a necessary but not sufficient condition. A planet needs a habitable zone. but it also needs an atmosphere to regulate its temperature, and water to begin with, and geological activity to cycle carbon through the system over time, and protection from the star's radiation, and probably other things we don't yet know about. TRAPPIST. One presents particular challenges in this regard. It is an active star for all its dimness, young and old. Simultaneously, old at 7.6 billion years in age, but faint red dwarfs age differently from sun-like stars, and TIAPPIST. One still produces significant ultraviolet radiation and stellar flares. These flares can strip planetary atmospheres over geological time. The innermost worlds almost certainly lost whatever atmospheres they started with. The outer worlds, E, F, G, have had the potential to retain theirs, but whether they have actually done so is still an open and passionately debated question. Elias had been following the James Webb Space Telescope results carefully in the years before this journey. In 2025, the first observations of TRAPPIST-1E had been published, and the results had been tantalizing precisely because they were inconclusive. 4 transits observed. The data suggested the planet had not retained its primary hydrogen-helium atmosphere, expected given the star's activity, but a secondary atmosphere, the heavier kind that planets can build through volcanic outgassing, the kind that Earth has? Possibly. The data didn't rule it out. The best-fitting scenario involved? Something like a warm, nitrogen-rich atmosphere with traces of methane. Something scientists had called a warm exotitan configuration. But other scenarios also fit the data. More observations were needed. More observations were always needed. The scientists needed more time. Elias had time. He descended toward TRAPPIST-1E, Part 9, TRAPPIST-1E, the IE-APOL world. There is a scientific concept called a tidally locked world, and it sounds technical until you think about what it actually means, and then it becomes one of the most poetic and slightly disorienting ideas in all of planetary science. TRAPPIST-1E, like all 7 worlds in this system, almost certainly keeps the same side facing its star at all times. Not day and night as we know them. Not a rotating world passing alternately through sunlight and shadow. Instead, one side of the planet is perpetual day, and the other side is perpetual night. And between them, there is a thin band of eternal twilight, a ring around the planet, where the star hangs permanently on the horizon. The sun never rises on the night side. The sun never sets on the day side. This has extraordinary implications for the planet's climate. If it has a climate, if the planet has an atmosphere, that atmosphere must work very hard to redistribute the heat from the permanent day to the permanent night. Or the day side bakes while the night side freezes. Models suggest that even a relatively thin atmosphere could maintain breathable temperatures across a much larger region than you might expect. There might be liquid water on the day side, in a region scientists have taken to calling the substellar point, the spot where the star is permanently overhead. And beyond that, spreading outward toward the terminator, the ring of twilight, there might be vast regions of moderate temperature, not too hot, not too cold, with the star always at an angle, never directly overhead, providing a gentle, perpetual dusk. Some scientists described a possible scenario for such a world as an eyeball planet. From space, the day side covered in water and possibly cloud would look bright. The center white or blue-white where liquid ocean or ice received the most light. The terminator region dark with clouds or rock. The night side invisible in darkness. An eye staring at its star. The pupil of light at the center. The iris of the transition zone. The dark beyond. Elias descended into the terminator zone. He had put on his suit purely out of habit and respect. The same way you put on good clothes to visit somewhere that matters to you. He moved through the airlock with the careful, deliberate attention of someone who has done this many times and has never lost the sense that this moment, the moment of crossing from ship to world, deserves a pause. The horizon here in the Terminator band was strange and beautiful. On one side, looking toward the star, the sky was dark red. Not the butterscotch of Mars, but something deeper, richer. A crimson red sky, the color of old wine, the color of a bruised sunset on Earth in winter. The star itself hung at the horizon, enormous compared to the sun's disk from Earth's surface, about 4 times larger in angular diameter, but far less bright, its red light diffuse and soft. It would never move from that position. It would hang there for the rest of geologic time, a permanent fixture of one side of the sky. On the other side, toward the night side, the sky was black. Directly overhead, the sky was something in between. A deep red-brown that faded to black. Stars were visible everywhere because the stars' reddish light was not bright enough to fully wash them out. The Milky Way crossed overhead in its familiar band, but the familiar constellations were gone. This was a different angle on the galaxy, 40 light-years from Earth, and the star patterns were different. Orion was unrecognizable. The Southern Cross was in a different place. The brightest star in the sky was yellow-white, and it was in a direction that Elias knew from the star charts was where the sun was. Our sun, a fairly ordinary yellow dwarf star, visible from here as just another point of light. Brighter than most, but only one of many. There was something deeply affecting about that. Standing here on this alien world and knowing that the sky point of light you were looking at was home. T-R-A-P. P-I-S-T. One E surface in the Terminator zone where he stood was rocky. The gravity was slightly less than Earth's, about 82%. The rocks were dark, volcanic-looking, worn smooth by whatever processes had acted on them over the billions of years this planet had been in orbit. In the distance, toward the day side, something glittered. Ice. The transition from temperature that was cold enough to freeze to temperature warm enough to melt, playing out over geography. Frost on the rocks, then wet rocks. Then in the distance, what might have been a pool of meltwater gathering in a low place. The models were riding up the frost. He stood very still and breathed his suit air and looked at the glitter of ice on an alien world. The star, this cool red ember, this tireless ancient fire, cast his shadow long across the ground, pointing away from the light toward the darkness. A thin, faint shadow. The star's light was not strong enough to cast shadows as crisp and dark as the sun does from Earth. Everything here was slightly underlit, slightly hazy with the star's warmth. Everything in that deep red tone. His suit, which was white, looked pink. He thought about the water. If there was an atmosphere here, and there might be, the James Webb data left room for it. And if that atmosphere contained enough greenhouse gases to warm the surface beyond its equilibrium temperature, then, somewhere on the day side, there was probably liquid water, maybe a lot of it. The models were particularly fond of a scenario in which the day side was covered in a deep ocean, or at least a large one, kept liquid by the star's warmth and the atmosphere's greenhouse effect. The night side would be frozen. The Terminator would be a zone of ice and slush and meltwater pools, transitioning from frozen to liquid and back, driven by whatever convective winds moved heat from day to night. In this scenario, which was one of several that JWST data did not rule out, TIAP, PIST, 1E would be genuinely a water world, not a metaphor, an actual world, mostly covered in ocean, orbiting a star 40 light years from home. And if there was water and warmth and chemistry, life on Earth began in water. As near as we can tell, the first living things were single-celled organisms that arose in the ancient oceans, probably around hydrothermal vents, where chemical energy drove the first metabolic reactions. They didn't need sunlight. They didn't need seasons. They needed water and chemistry and time. TRAP, PIST. One was 7.6 billion years old. The universe itself is only about 13.8 billion years old. Earth formed 4.5 billion years ago. There were billions of years of chemistry happening on these worlds before Earth even existed. Elias stayed in the Terminator zone for a long time. He didn't have any instruments sensitive enough to detect life. He hadn't brought a mass spectrometer or a biosignature analyzer. He was just a man in a suit on an alien world, looking at the glitter of ice and the dim red sky and the ancient star at the horizon, holding the weight of a question that had no answer yet. Are you there? He thought, toward the possible ocean beyond the frost line. Are you doing something interesting in the dark water? No answer came, which was expected, which was fine. The question was worth asking regardless. He moved carefully along the Terminator line, choosing his steps on the uneven dark rock, his boots finding purchase on a surface that had never been walked on before and might not be walked on again for a very long time. The rocks were unlike any he had seen on Mars or the asteroids, darker with a slightly different texture, formed in geological processes driven by TRAP, PIST. One's tidal heating rather than impacts and volcanism. Some of the rocks had a slight iridescence to them, minerals that caught the star's red light at certain angles and reflected something that looked almost like a deep purple shimmer. He had no idea what that mineral was. He made a note. The atmosphere, if there was one, and the data suggested there might be something, some thin veil of gas, was not apparent to his senses. The air in his suit was his own, recycled and filtered. Outside, possibly, the planet's own chemistry was present. Perhaps nitrogen, perhaps traces of methane, perhaps carbon dioxide, perhaps some combination of things that would tell scientists something important about the planet's geological history, if they could be measured. He was walking in potential, in possibility. Every step was on ground that might have something to say about life in the universe that hadn't been said yet. He found a ledge of rock that looked westward, toward the night side, toward the dark half of the planet where no sunlight ever fell, and temperatures plummeted to something close to the boiling point of nitrogen at sea level. From the ledge, he could look out over the dark terrain that began where the faint red glow of the Terminator faded. It was truly dark over there. Not the darkness of Earth at night, where the sky still has some brightness from scattered starlight and cities and the moon. This was the darkness of permanent shadow, of a place that had never felt the warmth of a star. Only the faint light of the stars themselves, thousands of them visible in that part of the sky, gave any illumination at all, and it was not enough to see by. If there was a night-side ocean frozen under ice, it was out there in that dark, possibly kilometers deep, possibly with a rocky seafloor warmed by geothermal heat, possibly with hydrothermal vents where chemicals circulated through hot rock and emerged into cold water, the same process that on Earth had been proposed as the birthplace of the first living things. Possibly home to something that metabolized sulfur compounds in the dark and had never once wondered about the sky because it had never experienced sky, never felt light. He had learned to hold the word possibly gently, not as a source of frustration, not as a hedge against disappointment, but as a genuine invitation. The universe was full of possibilities. The science was good and getting better, the instruments improving, the telescopes observing, the models being refined with each year of new data. Somewhere, right now, astronomers on Earth were analyzing light that had passed through this planet's thin atmosphere, if it had one, and looking for the fingerprints of specific molecules. Water vapor, methane, carbon dioxide, each molecule had its own spectroscopic signature, its own pattern of absorbed wavelengths, the way a key has a specific cut that only fits a particular lock. Find the right pattern, and you could say something true about a world 40 light years away, reading its chemistry from starlight. He turned slowly in a circle, taking in the full panorama of the Terminator zone. The rocks, the frost, the sky the color of deep space wine, the star at the horizon that would never move, the stars overhead that he recognized not by their patterns, but by their individual colors, the blue-white ones hot and young, the yellow ones middle-aged, like our sun, the red ones old and cool. He noted something in himself that always happened in these moments, a great settling quiet. Not the absence of feeling. He felt everything acutely, the awe and the solitude and the strange peace of being somewhere no one else currently was. But the feelings were smooth rather than jagged, present but not urgent, like deep water rather than turbulent water. This was why he did it, not just to see these places, not just to collect the data and the memories and the images, but for this, the settling, the clarifying, the way the universe, by simply being enormous and old and indifferent and beautiful, gave him back to himself in a simpler form. He sat down on a rock. The rock was cold through his suit. The red star sat at the horizon. The ice glittered. The stars turned slowly above him. He had nowhere else to be, nothing else to do. He was 40 light years from the place where he was born, on a world that may or may not harbor life, under a star that will still be burning long after the sun goes dark, on a rock that has been sitting here for billions of years. And all of this was completely fine. He breathed in and out. Part 10, The Long Way Home. drifting back through the stars. Leaving is always its own kind of visit. When Elias finally lifted off from the terminator zone of TRAP, PIST, 1E, or rather, when the Meridian's thrusters fired and carried him away from the surface and up through that wine-dark sky, he watched the planet recede with the same attention he always gave to departures. The frost glitter fading as the rocks grew too small to resolve. The Terminator band become an invisible feature of the planet's disk rather than a landscape. The planet itself shrinking into something viewable, a full disk, the day side a lighter red-brown, and the night side invisible, and the middle band, the twilight zone, the rim of perpetual dusk, just a line. Then he pointed the Meridian toward home. The return journey, like all return journeys, was different from the outbound one. Outbound, your attention reaches forward. You're moving towards something unknown. And the anticipation gives every moment a slight forward lean. On the return, the attention relaxes. You've seen what you came to see. The knowing is different now, richer, more specific. He had been doing this for a long time, these long journeys through the solar system and beyond. And he had learned something about the shape of experience over distance. The things you thought would be the most profound were often quieter than expected. The things you hadn't anticipated were sometimes what changed you. He had expected Jupiter to be the most overwhelming experience, and it had been extraordinarily. But what had stayed with him most viscerally, most permanently, was the sight of Mars from orbit on his very first journey. The long shadow of Olympus Mons at dawn stretched across the plain like a dark finger pointing at nothing. That shadow, that unexpected poetry of light and geometry on a distant world, it had rearranged something in him the first time and every time since. The interstellar dark was long. He slept more on the return, as was his habit. The long, deep sleep of the traveled, the kind that goes down to a smooth, undreaming depth where you're simply absent from yourself for hours at a time and wake rested in a way that is specifically different from any other kind of rest. He kept the forward viewport uncovered so that when he woke in the night, in whatever counted as night, out here where there was no day cycle, he woke to stars, hundreds of them visible through the small porthole above his berth, the Milky Way across one corner of the view, the cool, indifferent, perpetual stars. He passed through the heliopause again on the inbound track and felt the subtle shift as the Meridian's instruments registered the change. Solar wind particles beginning to populate the readings, the sun's magnetic field reasserting its influence. Voyager 1 had taken 35 years to reach this boundary. Elias had taken rather less time than that. The universe, in the logic of this journey, was navigable. The distances were real, but not imprisoning. Neptune appeared first. Then, weeks later, Uranus, a soft blue-green glow that he waved at fondly as he passed. Then Saturn, its rings briefly spectacular in the slanted light as he made a close approach to get a gravitational assist, swinging around the planet in a long arc that ate up his speed and then gave it back in a different direction. The rings were doing what they always did, being improbable and magnificent. He spent 3 hours in close approach and took 1,000 images that he knew he would spend years looking at. Then Jupiter, enormous and turbulent and alive, the great red spot still there, the moons in their orbits, everything as it was and would be for a long time to come. Then the asteroid belt, those quiet rolling stones. Then Mars, orange-red in the middle distance, its thin atmosphere catching the sun and giving the limb a faint orange glow. And then, finally, profoundly, simply, Earth. There is no way to describe what Earth looks like from space without sounding like you've borrowed someone else's words. The photographs have been taken thousands of times by hundreds of missions. The pale blue dot, the Earthrise image, the blue marble. These are some of the most famous photographs ever made. And they are famous for exactly the right reason, which is that they are genuinely astounding and they make you feel something. But seeing Earth from space in person, not in a photograph but through an actual viewport, is different in the way that all first-person experience is different from mediated experience. The color is the first thing. Not blue exactly, blue and white in proportions that shift depending on cloud cover, depending on which hemisphere faces you, depending on the angle of the sun. The clouds are brilliant white, brighter than anything else in the image. The ocean is every shade of blue, from pale turquoise near the coasts to deep midnight in the mid-ocean troughs. The land is brown and green and tan and gray. The poles are white. The whole thing is wrapped in an atmosphere so thin you can see it only as a faint blue halo. At the edge of the disk, a barely there veil of air, the entire atmosphere, the stuff that every living thing has ever breathed, visible only as a rim. Elias had been away a long time. He sat in the pilot's chair and looked at Earth for a while before beginning his approach. He thought about all the planets he had visited, the red dust of Mars, the colossal storms of Jupiter, the impossible rings of Saturn, the quiet green-blue of Uranus, the vivid stormy blue of Neptune, the red wine sky of the TIA, PPIST, 1E Terminator. Each of these worlds was real. Each was there, going about its geological and meteorological business, indifferent to whether anyone was watching or not. The diamond rain inside Uranus, falling through conditions no camera has ever seen. The geysers of Triton, erupting in the dark. The tide-locked ocean of an alien world, possibly full of life, that has never once needed to worry about what the sky looks like because it has never experienced sky. He brought the Meridian in, slowly. The atmosphere thickened around him. The first blue haze of the mesosphere, then the stratosphere, then the troposphere with its weather and its clouds. He watched the clouds resolve from above, their tops first, those brilliant white formations that from below look like castles or animals, but from above look like the floor of a different world. A white landscape of cumulus and stratus and the spiraling arms of weather systems. He broke through the clouds at about 3 kilometers, and below him was green land, trees. He could see individual trees after everything, after the geological vistas of Mars and the titanic scale of Jupiter and the frost glitter of a world 40 light years away. He could see trees, small, specific, ordinary trees, green in the ordinary sunlight of a star he knew, on a world he had always called home. He landed. He sat in the pilot's chair for a moment after the engines went quiet. The hum of the ventilation was still there, the familiar tick of the hull in Earth's atmosphere, different from the tick in space, louder, more frequent, the hull warming from the friction of re-entry. Outside the viewport, there was sky, real sky, the brilliant, actual, unrepeatable blue of an Earth sky on a clear day, a color that Elias had now compared to every other sky in the solar system and could say with authority was not matched anywhere else. Not the butterscotch of Mars, not the wine dark of TRAP, PIST, 1E, not the total black of space. Just blue, ordinary and extraordinary, the blue that the whole planet wears. He opened the hatch and the air came in. It was cold and it smelled of grass and distance and something wet like rain had happened nearby. It smelled of earth, the way things only smell when you've been somewhere else for a very long time. Overwhelmingly specific, overwhelmingly full of information, overwhelming in the way that coming home is always overwhelming even when you know every corner of it. He stood in the hatchway for a moment. He breathed. Part 11. Settling down. The last light. Elias did the same thing every time he came home. He found a place to sit outside. A hillside, a field, sometimes just a patch of ground beside the landing pad. And he sat down on the actual Earth and looked up at the actual sky for as long as he wanted. He did this even in the rain. He did this in winter, when the ground was cold. The sitting was part of the decompression, the long process of scaling back from the vantage of planets to the vantage of a human person on a hillside. Tonight, it was evening. The sky in the west was doing the thing it does in the last minutes before dark. That sequence of colors that begins in orange and moves through pink to purple to indigo in a progression that never takes more than 20 minutes, but never feels rushed because each stage is complete in itself. Each moment of color has its own stillness. He watched it happen without trying to hold on to any part of it. The orange faded, the pink faded, the purple deepened and spread, and then there was the first star. He always noticed the first star. Tonight it appeared low in the west, just above the point where the orange had been. Venus, probably, or Jupiter, he checked automatically without meaning to. The star recognition, a habit so old, it happened without thought. It was steady and bright. And as the sky continued darkening, more stars appeared, one by one, and then in groups. And then, all at once, the whole inventory of what was visible from this latitude on this night, appearing overhead in their familiar patterns. He found TRAP, PIST, one's location in the sky. He knew which part of Aquarius to look in. There was nothing visible to the naked eye there. TRAP, PIST. One was far too dim to see without a telescope, even under perfect conditions. But he looked anyway at the patch of sky where he knew it was, and he knew that there, in that direction, was a small red star with 7 worlds. And that one of those worlds had ice on its rocks, and a Terminator sky, and the possibility of an ocean where for 7.6 billion years, chemistry had been doing whatever chemistry does when it has enough time and warm water. He stretched out on the grass. The ground was slightly damp. He could feel the specific weight of Earth's gravity, not the 82% of TRAP, PIST, 1E, not the theoretical weightlessness of deep space, but the actual, familiar 100%, the gravity he had grown up in. it pressed him gently and completely against the planet. The stars moved overhead as the Earth turned. This was the thing. Not the stars moving. It's the Earth that moves, and the sky that holds still, and you lying in the grass and turning with the planet through the night. Everything else out there, all those worlds he had visited, was doing the same thing, spinning, orbiting, following the curves of space-time in their long, elegant arcs. He was just another body doing the same. A small, warm, conscious body on a hillside, participating in the same physics as the Great Red Spot and the TRAPPIST. One system and the rogue planet in the interstellar dark. He closed his eyes. The sounds of Earth at night came to him. Insects, the small, insistent, beautiful sound of insects in grass, that sound which is so specifically alive it almost aches. A distant bird. Wind in the nearby trees, a sound quite different from any wind he had heard in a suit on Mars. Lower, fuller, carrying moisture and organic smell, the sound of air that has been breathed by everything. And beneath all of it, the sub-base of Earth itself, the geological rumble of a living planet, the heartbeat of a world that is constantly moving, constantly making, constantly cycling elements through rock and ocean and air and life and back again. He felt himself getting heavy, not uncomfortable heavy, the comfortable kind, the kind where the weight of your body on the ground begins to feel like the most natural arrangement in the world. Because it is the most natural arrangement in the world. It's exactly what you're built for. The specific gravity of this specific planet calibrated exactly to the biology that evolved here. He sank into the grass. The grass was soft. The ground was cool. The stars moved slowly overhead. He thought about TRAPPIST, 1E, and the frost. He thought about Saturn's rings and how they scatter light. He thought about the small, steady lights of the Meridian's instrument panel, the amber and green and quiet blue, and how they had been his sky for so many months of travel. He thought about the Great Red Spot jiggling like a bowl of gelatin through its 90-day oscillation. He thought about the diamonds falling in the dark inside Uranus. He thought about the first star he had seen from orbit, sharp and unwavering without atmosphere between him and it. All of it was there, even as he lay in the grass. All of it existed simultaneously. All those worlds going about their business in the dark. Mars cooling as the Martian night advanced. Jupiter's storms churning. Saturn's rings catching no light on the night side. TRAPPIST, one burning its patient red for the next 10 trillion years. And he was here in the grass, heavy and warm and home. His breathing slowed. The insects continued their small, continuous song. The sky turned, and Elias, the planet explorer, who had seen more of the universe than almost any human being who had ever lived, who had stood in the terminator zone of a world 40 light-years away and looked at frost on alien rock under a crimson sky, let himself do what every body eventually needs to do, what consciousness gracefully surrenders to after a long, full, extraordinary day. He slept, and in his sleep, perhaps the planets were still there. Jupiter vast and turning, Neptune impossibly blue at the edge of the known, all of it continuing without him, all of it patient, all of it waiting, as it always would be, for whenever he was ready to go again. But that was later. Right now, just now, in this moment, just the grass and the stars and the slow, even breath in and out and in. If you're still with me, if you haven't already drifted off to somewhere quiet and dark and restful, that's okay too. There's no hurry here. The universe is large and it will wait for you. All those worlds are patient. All that space is still. Let your body be as heavy as it wants to be. Let the bed, the pillow, the warmth, let all of it hold you. You don't need to hold yourself up right now. That job is done for today. The stars are outside, being stars. Sleep well. If you enjoyed this journey, please like this video and subscribe to the channel. It helps more travelers find their way here. And if you'd like to visit another world together, you know where to find us. Good night.